All right, this is the Unit 3 Study Guide, Part A. Some of these questions are a little bit long, so in order to make sure that you can see the bulk of the information, I have the left side of the page visible to the screen. A plot of land is rectangular and has an area of x squared minus 5x minus 24 meters squared. The length of this particular plot of land is x plus 3 meters. Find the width. Well, we know that we calculate area as area is equal to length times width. And we have been told the value of the length. We're trying to identify the value of the width. Well, it appears to me that we have two values when multiplied together equal the area. That sounds a lot like two factors. So the very first thing I would do, since we have not learned synthetic division to be able to divide the trinomial by the binomial, we're going to simply identify the factors of our trinomial to determine if we're going to have a quick and easy solution. So let's start with our trinomial. Our trinomial has three terms, and we can see that the leading term has an a value of positive 1, which means we can quickly factor using our x games. We want two numbers that multiply together to give us negative 24. We want two numbers that add together to give us negative 5. And so we want to start going through our factors. Now, hopefully you're thinking 8 and 3 multiply to give you 24, so it's got to be some combination of 8 or negative 8, or 3 or negative 3. Well, we need to get to a negative 5, which means our larger term needs to be negative, so negative 8. Our smaller term needs to be positive, so that we will reduce down to negative 5. So that gives us the factors x minus 8 and x plus 3. Well, again, like we said at the beginning, we're looking for two terms when multiplied together give us a specified area. These two terms, when multiplied together, give us the area x squared minus 5x minus 24 meters squared. One of them is determined to be our length, so the other must be our width. So our width is x minus 8 meters. Question number 2. The area of a poster board is x squared plus 3x minus 10 inches. The width is x minus 2 inches. Write an expression for the length of the poster board. Find the dimensions of the poster board when x is equal to 14. Write a polynomial for the area of the poster board if 1 inch is removed from each side. So we have a couple of different things we're looking for. The first thing we're looking for, we've got the width, we need the length. This sounds a lot like the previous question. So I'm going to start with trying to factor. My a value is a positive 1, so again we can use our x games. We have a negative 10. I have a positive 3. I need two numbers that multiply together to give me negative 10 and add together to give me positive 3. So maybe something like a positive 5 and a negative 2. So x plus 5, x minus 2. Those are my factors. Well, x minus 2 was our width, so our length has got to be x plus 5. Our expression, x plus 5 inches. Now it asks, find the dimensions of the poster when x is 14. Well, the dimensions are simply the length and the width. So we were told that the width is x minus 2. We were told that we know that the length is x plus 5. And since we are given a value of x, we're going to plug that in. So our final solution, 14 minus 2 would be 12. by 14 plus 5 is 19. So we have a 12 by 19 inch poster board. Part C. Write a polynomial for the area of the poster board if 1 inch is removed from each side. Okay? So if I have the x plus 5 and we subtract 1 from it, we're going to be left with x plus 4. And if I have an x minus 2 and we subtract 1 inch from it, I'm going to be left with an x minus 3. Now it's great to know what the values of the new length and width are, but we're not asked for that. We're asked for the area. So we need to take these two values, because area is equal to length times width, and multiply them together. So area is equal to x plus 4 times x minus 3, and we need to FOIL. X times x is x squared. X times negative 3 is minus 3x. 4 times x is plus 4x. 4 times negative 3 is minus 12. All right, let's clean that up and give ourselves a final answer. X squared, combine negative 3 and positive 4, gives me a plus x minus 12 inches squared. All right, the area of an addition. Notice I've given you some reference points on the chart. You're not going to be able to see it while I have the question showing. The area of the addition is x squared plus 10x minus 200. What is the length? All right. Well, in order for us to find the length, we need to know something about the addition. That's x minus 10. But we're looking essentially for two values that multiply together, and our whole focus for this unit has been factoring. So I'm going to start with factoring this trinomial. So give myself my x games, put my c value down in the bottom, my b value up top, and we want two numbers that multiply together to give us negative 200, add together to give us 10. Well, 10 times 20 is 200. So if one of them was negative, maybe something like the negative 20 and a 10. Wait, nope, that's going to give me a negative 10. How about a positive 20 and a negative 10? Well, that would do it. So my factors are x plus 20 and x minus 10. Well, I can see over here on the addition that x minus 10 is one of the dimensions for our particular shape. So x minus 10 is not going to be the length, it's going to be our width. Which means the other dimension, x plus 20, has got to be our length. And sure enough, D is an x plus 20 feet. Question number 4, what is the area of the original house? Well, the original house only shows us the width. It's got a width of x plus 10. But in the previous question, we determined that the length of the addition was x plus 20. So if the length plus the addition is x plus 20, then the length of the original house is also x plus 20. So we have an x plus 20 length. We have an x plus 10 width. And we're simply going to FOIL again. X times x gives me x squared. X times 10 gives me a positive 10x. Oh, wait. There we go. 20 times x gives me a 20x. 20 times 10 gives me a 200. And we combine like terms. X squared plus 30x plus 200 is going to be the area of the original house. And again, that appears to be answer D. The homeowner decides to extend the addition. The area with the addition is now x squared plus 12x minus 160. By how many feet was the addition extended? All right. So we're looking for the difference between one addition area in a previous problem and a new addition area and a former addition area in the current problem. We can tell that this one was the former because our C value is 160, which means our factors are going to be smaller. Whatever. All right. So, in order for us to figure out how many feet were added to the extension, we're going to need to factor. So, again, I see my A value is a positive 1, so we're going to use our X games. We're looking for two values that add or multiply the negative 160, add together to give me 12. It looks to me like a 20 and an 8. 2 times, yep. So 8 times 2 is 16. Add the zeros, 160. I need to get a positive 12, which means I need my 20 to be positive and my 8 to be negative, so that when we add them together, we end up with 12, which means my factors are x plus 20, x minus 8. All right. Well, how many feet were added to the extension? X plus 20 is still the length of the house. Nothing was changed there. But notice, we went from an x minus 8 to an x minus 10. So what is the difference? The difference is 2 feet. Oops. Didn't need that D over there.